I've worked as a quant for 4 years, and here are some questions that everyone should be able to derive. What's the sum of 1 to 100? And then, what's the sum of 1 squared to 100 squared? And what's a generalizable formula to solve these summation problems? As a note, Gauss famously solved the sum of 1 to 100 when he was only 10. He noticed that you can pair up the numbers together, like 1 with 100, 2 with 99, 3 with 98, to create 50 pairs of a sum of 101. So that gave the sum of 1 to 100 to be 50 times 101, which is 5050. We can generalize this formula by thinking about the problem as if we were adding together blocks in a triangle, where the block of 1 goes up to 2 blocks, 3 blocks, all the way up to n blocks. An easier way to solve this is to double this triangle and flip it around to create a rectangle. And this rectangle represents 2 times the sum of 1 to n. And the dimensions of this rectangle is n by n plus 1. Therefore, the sum of 1 to n is just n times n plus 1 divided by 2. Now with the sum of 1 squared to 100 squared, we can start by considering the function of I plus 1 cubed minus I cubed. If we took the sum of this function from I equals 1 to n, we would get n plus 1 cubed minus n cubed plus n cubed minus n minus 1 cubed, so on until the last term of 2 cubed minus 1 cubed. And all the inner terms of this cancel out, leaving us with n plus 1 cubed minus 1 cubed. We can then expand the terms out of n plus 1 cubed to being n cubed plus 3n squared plus 3n plus 1. The ones cancel out, and that leaves us with an answer of n cubed plus 3n squared plus 3n. I'll call this equation 1. Now going back to our I plus 1 cubed minus I cubed, instead of doing the summation from 1 to n now, let's first break down I plus 1 cubed. That's equal to I cubed plus 3i squared plus 3i plus 1. Now the I cubed terms cancel out, leaving us with an equation of 3i squared plus 3i plus 1. We can now apply the summation to all of these individual components. The sum of 1 is just n, and the sum of I is just n times n plus 1 divided by 2, or n squared plus n divided by 2. And now we can combine both of the n terms, and we'll call this overall equation 2. Now I plus 1 cubed minus I cubed is equal to I plus 1 cubed minus I cubed, and therefore equation 1 equals equation 2. We shift all the n terms onto the right hand side and then simplify it. We multiply both sides by 2 to remove the fraction component, and then we can factor out the right hand side, which is equal to n times n plus 1 times 2n plus 1. Now we divide both sides by 6, and that gives us our final answer. The sum of I squared from I equals 1 to n is equal to n times n plus 1 times 2n plus 1 divided by 6. Follow for more fun math content, and next time I'll show you how to derive the sum of I cubed. And just to finish this video off, the sum of I squared from I equals 1 to 100 is 100 times 101 times 201 divided by 6, or approximately 338,000.